In this video, we're going to use the result of problem 1 to evaluate the integral in problem 2. And I may have done this problem in another video as part of another video, but just in case, I'm going to do it here. So for number 1, I'm going to use a U-substitution. Let u equal to ln of x. Then du would be the derivative of ln of x, which would be 1 over x dx. And then I would just rewrite this integral in terms of u. Now I could solve this for dx and then make the substitution, but notice here I have dx over x, right here, dx over x, and this is the same thing as dx over x. So I'll replace the dx over x by du. And the ln, of course, of x will be u. So this will be the integral. This is u, and dx over x is your du. Now we just integrate with respect to u. Basic integration, and this will just give me, add 1 to the exponent there, that's 2, divide by 2, and then it's plus the constant of integration. And then we just go back to the original variable here, so u, of course, is ln of x, and that's squared over 2, and this is plus the constant of integration. And that's the answer to number 1. Now for this one, I'm also going to use a U-substitution. Again, I'm going to let u equal, now remember this is a separate problem, so I could pick another variable like t or whatever, w, but I'm going to pick u again here. So in this case, I'm going to let u equal to x squared plus 1. And then du would equal to the derivative of x squared plus 1, which would be 2x. And it's multiplied by dx. So this is going to be equal to then the integral, and it's going to be ln, and this is your u here, x squared plus 1, that's your u, so this will be ln of u, and then I have x dx right there, so we put this together, dividing by 2 here, and by 2 over here. Then I can replace the x dx by du over 2. So I'll put the 1/2 over here, and then I've got the du, put it there. And of course the denominator x squared plus 1, that's your u. Now notice, problem 1 now, ignore the 1/2 here, but ln x over x basically is the same setup as ln u over u. This is just a variable. It could be u, it could be x. So that tells me then that when I have an integral of this form here, in this form I'm going to use this result over here. It's going to be whatever this is, squared. So it's just going to be ln of u squared. But remember, we always go back to the original variable. So this is going to be ln, and u, of course, is x squared plus 1. For the second problem, u is x squared plus 1. So I'll put x squared plus 1. And remember, this quantity is now squared. So I'll put this in brackets instead of parentheses. So we squared. And that's over 2. But I already have the 1/2 there. So that's going to be like 1/2 times 1/2. So I'll put this over 4. And then it's a constant of integration. So that's the integral for problem 2. Now you could go ahead and work problem 2 without using problem 1, but you'd have to go through the same thing. You'd have to go through this substitution here, and you would get this setup here, and then to evaluate it from here, we'd have to kind of repeat this same procedure over here. But I thought it'd be more convenient just to make a separate problem over here, and then just use the results for this one. Thanks for watching. We'll see you next time.